Welcome back, everyone. We are going to talk about the rest of our simple machines in this video. I'm going to break it down, and I'll probably do one video at a time. So I think in this video we'll do the inclined plane. And so let's dive right in. All right, so again, before the simple machines we used before were lever, wheel and axle, and pulley, and now we're going to use the inclined plane, wedge, and screw. The reason they split them up is because in the other one, the lever was kind of the base one, and this one, the inclined plane. So the inclined plane is a simple machine. It's basically just a ramp, and it is the basis behind both the concepts for the wedge and the screw. Quick review of mechanical advantage. It's just making a ratio of how much it makes your life easier, basically. We covered that in previous videos, so I'm going to skip through this a little bit and get into inclined plane. Okay, so the inclined plane is a let me minimize this. Inclined plane is a flat surface set at an angle or an incline. It has no moving parts. All you're doing is you're pushing a weight or a resistance of some sort up the ramp. So instead of lifting it from the ground up, ground up, you're pushing up the ramp this way. There we go. Okay. Let me see if I can clear my screen here. There we go. Okay. So inclined plane is making our life easier, but the contrast or the trade-off is that we have, instead of lifting it from here up, we have to go a further distance up the ramp, but it's a much easier task for us to go up the ramp. So IMA for an inclined plane is still the same as all of our other IMA equations. It's dE over dr, and just like with our other equations, it's just where do we put the distances that we're looking at. So I have the distance that I'm applying the effort, and I have the distance that my resistance is going. So in the picture here, we have this cart, and the cart would be starting down on the ground, and we're slowly moving up the ramp this way, okay? And so my distance of resistance is from starting on the ground right here up to this final point at the top, which is the same equivalent as our height of our ramp right here. So right here, this H is our distance of resistance, and then we're pushing up the length of the ramp, and so actually up the slope is our distance of effort. And so with inclined planes, they also write the equation for IMA as L over H. The biggest thing to remember is that it is not if we're thinking of it as a triangle, it is not this distance here. It is the length of your slope and the length of your height. So we don't worry about this distance at all. Sometimes they are going to give us that distance, and they're going to give us the height. So maybe you have a picture like this, and sometimes they're going to give us this distance here and this distance here, and we need to figure out what is our slope so we can do our mechanical advantage equation. Well, if you remember how to do that, it's just a triangle now. So we'll call our slope C. So if you remember Pythagorean's theorem, a squared plus b squared equals c squared, sometimes you'll have to find that slope. And so C is going to be equal to the square root of a squared plus b squared. Keep that in mind when you're moving forward that way, okay? Let's just leave it at that. I think it'll go away. Oh, they did a quick calculation. Sorry. I'll clear my screen. IMA of the inclined plane above, the length of our slope was 15 divided by our 4-foot height. So we have 3.75 to 1 or 3.8 to 1. Okay. Actual mechanical advantage is the same concept. We have FR over FE, and that's pretty simple. Our resistance force is just whatever it is we're moving up the slope. The effort is what are we pushing with to push it up the slope that way. So FR over FE in this case, 50 over 20, we have a 2.5 to 1 mechanical advantage. And if we're looking at efficiency, it's still just AMA divided by IMA. So from before, our IMA was 3.75. So we have 2.5 divided by 3.75 to give our, times 100 to give ourselves a 67% or 66.6 probably, somewhere in that range, percent efficiency. All right, so that wraps up the basics of the inclined plane. In another video, we'll go through some more examples. And in the next video, we'll talk about the wedge.